Hi, today we are diving into an essential concept in software architecture, component cohesion. A few years ago, I came across a situation where before starting any of the changes for that particular feature delivery, I had to move several classes from one component to another. As many of you, I believed that this knowledge on how to move classes between components comes from experience or rather from maturing inside a single project for a long time until I learned about component cohesion principles in clean architecture. So, if you master these principles, you can easily identify how a component should be organized with classes inside that, making the component reusable as well as resistant to changes from external components. So, we will explore three fundamental principles that guide us in deciding which classes belong in which components and how these principles work together to create better software systems. At the end of the video, I will assign you a task in which you will evaluate how well you have organized your components based on these principles. So what is component cohesion? Component cohesion addresses a crucial question in software development. How do we decide which classes should be grouped together in components? Historically, these decisions were often made ad hoc, but today we have three key principles to guide us. The reuse release equivalence principle or REP, the common closure principle or CCP, the common reuse principle or CRP. Let's explore each of these in detail. First, let's discuss the reuse release equivalence principle or REP, which states that the granule of reuse is the granule of release. In today's software development landscape, we use tools like Maven, Gradle, and npm for module management. These tools have become crucial as software reuse has become more common. The reuse release equivalence principle tells us that components must be tracked through a release process, which means that changes to a component should result in a new release of that component. Further, the release process must produce the appropriate notifications and release documentation so that the users can make informed decisions about when and whether to integrate the new release. They need proper version numbers so that we can roll back as needed and support users of both latest and previous versions. Classes in a component must form a cohesive group so that the classes in a component are distinguishable as serving a single purpose. Components should make sense as a releasable unit because otherwise those violations are easy to detect by the users of your components. Think of it like publishing a book. You wouldn't release random chapters separately. They need to form a coherent whole. Next is the common closure principle or CCP, which can be summarized as gather into components those classes that change for the same reasons and at the same times. This principle is essentially the single responsibility principle applied to components. Here's why it matters. First of all, we want the code to be maintainable before it is reusable. Changes should be confined to single components when possible. You don't need to redeploy components unnecessarily which have no direct connection to the feature you are building. It's closely tied to the open close principle, and because 100% closure is not attainable, we have to design our classes in a way that they are close to the most common kinds of changes that we anticipate. Consider it like organizing a toolbox. You keep related tools together because you will likely need them for the same task. The common reuse principle or CRP states don't force users of a component to depend on things they don't need. Key points about CRP are Classes that are reused together should stay together in a single component, and that we should see a lot of classes intertwined together. Dependencies between components should be meaningful, such that a dependent component should require changes only if the changes in the parent component really impacts the dependent component and not because of just version update. All classes in a component should be inseparable such that it should be impossible to depend on some classes and not on the others. It's similar to the interface segregation principle that we learned in solid principles. Think of it as a restaurant menu. You wouldn't want to order just a burger but be forced to pay for a full 3-course meal. These principles often compete with each other, creating what we call a tension diagram. RAP and CCP tend to make components larger, while CRP drives components to be smaller. Hence, finding the right balance is crucial. One interesting thing is that the balance point changes as projects mature. Early projects focus more on CCP and hence on developability, while mature projects shift towards RAP and reusability. Now is the action time. First, I want you to identify classes inside your components. Next, I would ask you to check whether all those classes are being used by their respective components. If not, this is a violation and we would need to rearrange our classes in the components. Next, we need to evaluate if any of the classes require changes when any external component or class changes. If so, this is another violation and I want you to think, how can you move classes between components to validate component cohesion principles? Finally, are there classes performing similar actions in different components? If so, can you extract those classes into a new component and reuse that component in the previous ones? However, there is one caveat to this. If the new resultant component requires frequent changes, this approach would not work because changes in this new resultant component would require recompiling its parent's components unnecessarily. So when you extract those similar classes, those should be pretty stable, which do not require frequent changes. That wraps up our discussion on component cohesion principles, and please share your thoughts in the comments. Thank you for watching. Don't forget to like and subscribe for more software architecture content. See you in another video. Until then, happy coding!